Hey, you kids gotta go down to the beach for a minute. I gotta make this. Hey, aloha, amigos. This is Mr. Picard, and we are on our last day, Friday. And I'll be back on Monday, so if you're a little frustrated with this stuff, don't worry. We're gonna work on it a little bit more. No big deal. We're gonna start out with a little bit of a word problem here today. It says if f of x equals 5x squared plus 3x minus 2 represents the length of a rectangle, and g of x equals 4x plus 25 represents the width of a rectangle. Write a function that represents the perimeter of the rectangle. Well, what's the first thing you should do with this problem? I'll let you think a little bit. Well, definitely you should draw a rectangle and label it. Now, it's not numbers or constants per se, it's functions. It says f of x here, this whole thing represents the length. I'm just going to put a little f of x here and here. And I know it's 5x squared plus 3x minus 2, but we don't need to write all that. We can just write f of x. And then g of x is the width. Gee whiz, huh? Okay. Now it says write a function that represents the perimeter of the rectangle. Okay. So I'm going to use the titles here for a little bit, little shortcuts. But eventually we'll get into the function part of it. If I were going to do the perimeter, it's the sum of all sides. So that's f of x plus g of x plus another f of x plus another g of x. And you can simplify this just by combining like terms. It's the same thing. Let's do this. I could plug in right here the 5x squared plus 3x minus 2 for this f of x and this f of x. I'd end up with 3 here and 3 here terms here. I could plug the 4x plus 25 in here, and then combine all the terms. But we're going to do a little shortcut. F of x plus f of x is just 2 f of x because there's 2 of them. Plus another g of x plus g of x is 2 g of x. So basically you're multiplying 2 by the f of x function, then adding it to 2 times the g of x function. And the way this works is, well, 2 times, well, what is f of x? 5x squared plus 3x minus 2. All I did was plug in what this title of this function is actually equal to, plus 2 times the g of x function, which is 4x plus 25. Well, we got the expression part in there for our functions now. This is the title, the f of x and the g of x. These are the expression parts, and these are the parts that we're going to work with. So what do we got to do to simplify this? Get rid of parentheses. Use the distributive property. So I'm going to get 10x squared plus 6x minus 4 plus 8x plus 50. And then just combine all the like terms and you're done. You'll have your expression for the perimeter of this rectangle. So there's only one x squared term, 10x squared. We have a couple x terms, 6x and 8x is 14x. And then negative 4 and 50 is plus 46. There is our perimeter. And we're done. So you might see a problem like that. And it really wasn't that bad. Okay, just learning how to work with the notation again, this g of x and f of x. And we're going to cruise down here. We're going to boogie board down here to, oh, wait a minute now. We worked with this yesterday, composition of functions. You guys are going to do some more with composition of functions today. And here we go. We're going to try number 5 here. This should be on your note sheets or your note sheet. And this will be the last one we do until I see you on Monday. Here it is. It says find f of g of x if this is f of x and this is g of x. Okay, it's written f of g of x, so that's already taken care of. This is really, you could write it like this, f of g of x, fog of x, whatever you want to call it. But it's set up nicely. We're going to find f of, well, g of x. What is g of x equal to, though? It's equal to 2x minus 1. So we're going to plug in 2x minus 1 for x, wherever we see x, in this function right here, f of x. And I only see it once, but it is squared, so we got to be careful. This is 3 times 2x minus 1, but this is x squared up here, so we got to put a little squared. Okay, and then that's the 3x squared. Now we got to remember the minus 4 also. Okay, so all we got to do is simplify this, and we're done. So it's going to be, okay, this is not power 2 power. It looks like it, I know, but there's two terms here, the 2x and the negative 1. So I can't just distribute that 2, that exponent in there. I have to say 3 times 2x minus 1 times itself twice. So 2x minus 1 times another 2x minus 1. And then finally, minus the 4 here. A couple different ways you could do this. You could FOIL these two right away. But what I'm going to do is I'm multiplying 3 things here. 3 times 2x minus 1 times 2x minus 1. I'm going to distribute the 3 first. And I don't do it to both of them, okay? Because it's 3 times 2x minus 1 first, then take that and multiply it by the next 2x minus 1, or the last 2x minus 1. So this ends up becoming a 6x minus 3 times 2x minus 1. This is no different than 3 times 2 times 4. I wouldn't say 3 times 2 and 4. I'd just say 3 times 2 is 6 times the 4, and that's 24. It's no different than order of operations. There's no addition in between this 2 and the 4 here, so I don't multiply the 3 by both of them. Okay? That's kind of what we're working with there. Don't forget our minus 4 over here. Now I can use the distributive property. I get 12x squared minus 6x, and then multiply the 3 times the negative, or I'm sorry, the negative 3 times the 2x and get another minus 6x. Negative 3 times negative 1 is, careful, positive 3. Finally, minus this 4 on the end. And all we got to do, combine our like terms. There are 2 of them in this case, the negative 6x's, so it's 12x squared. This gives me minus 12x. And finally, we got 3 minus 4 is negative 1. Right here, 3 minus 4, negative 1. And we're done. I think I did that right. So, yeah, that looks good. If you have any questions, ask your teachers, or I'll be helping you guys on Monday. ¿Qué pasó? Oh, before I forget, make sure you take your quiz. Once you're done with your quiz, check with your neighbors and check with one of the teachers. You guys can start on your worksheet, your Friday's worksheet. See you Monday. Now I can go.